Hey everyone, what's up? Are1or0 here. Today we're together for IAMVulnerable part 2. If you did not watch the first video, I highly recommend to check it out. In the first video, I covered how to set up the environment for IAMVulnerable, which is a playground with different AWS misconfigurations. So I showed 5 scenarios in the first video, how to exploit these misconfigurations to escalate our privileges. So today we're going to cover another 10 privilege escalation scenarios. I think I covered all of the scenarios or most of them. And yeah, we are going to cover different services, IAM, EC2, Lambda, CloudFormation. So it's quite cool. So enough with the chit chat, let's get started. First one is Privesc 8. So let's go to the user under IAM users. We are checking which policy is attached to it. And as you can see, the action allowed is IAM attach group policy. The first action that we do is go into the AWS documentation. You can check what this policy stands for. It mentions attach the specified manage policy to the specified IAM group. And if you want to see how to use the command line option, there is also the link at the end of the page. So that's my strategy for every single one of these. I'm checking the documentation and I'm also checking the command line options to see how can I exploit this. We're also in this user group that I'm seeing, which will be useful for this exploitation. So here's the comment: AWS IAM attach group policy. We're writing the group name which we are in, Privesc attach group policy dash group. We're gonna attach that one here. Now we're going to give the policy ARN. We can get just the default policy managed by AWS, which is administrator access, because we want to have full privileges, and administrator access is the perfect example for that. Just go to policies, search for administrator access, go there and copy the ARN. Paste it in here. We're going to give the profile, which is Privesc 8. Again, these are all discussed in the first video if you don't follow right now. It shouldn't give any output. That means we are good to go. We're going to go to the group to check the permissions, and we are seeing administrator access. So since we're in this group, we now have administrator access. So super easy, straightforward. All right, the next one is Privesc 9. And let's see what kind of policies do we have. So we went to the users, Privesc 9, attach role policy user. We're checking the policy and it's IAM service, and the action is attach role policy. We have the effect all. And we are going to the documentation. It says attaches a specified manage policy to the specified IAM role. So we're checking the roles here. There's this Privesc 9 attach role policy. You're seeing the same policies given in here, attach role policy. So let's see how we can exploit that. If you go to the AWS documentation for command line interface, it will show which options are available for attach role policy on IAM. So the next thing we need to write is role name. I already showed you which role name was having this policy, attach role policy. We found it out. And then the policy ARN that we want to attach to is going to be the same as the previous example, just administrator access policy, which is a AWS managed policy. It's not a customized one. We are seeing it there. ARN, copy paste here. We're going to get the profile, obviously, which is Privesc 9. It should be. And in this way, we are attaching the policy to the role. Again, we're not getting any output. That means we're good to go. No errors. When we refresh the page for the role, we're going to see administrator access attached to it. The next one is Privesc 10. So let's see the Privesc 10 user we found under the users list, and we're going to see which policy is attached to it. It's called put user policy, and let's expand this. Yes, I am put user policy. What you can do is immediately go to the documentation, To see what it is, it adds or updates an inline policy document that is embedded in the specified IAM user. You can also learn more about managed policies and inline policies in here and the documentation if you'd like to learn more about it. So I'm assuming you checked the command line interface document. I'm not sure in here, but that's how I solve all of these exercises here. So let's see what kind of command line option we have for put user policy. So let's figure it out. It's AWS IAM, the service name, and then the option here that we have as the action, put user policy. If you check the documentation on the command line interface, it gives which kind of options are available for this command. We're going to get the username as peresc10, put user policy -user. The policy name that we're going to give is you can just pause, you can just write it anything. Since we read about inline policy, I'm just calling it new inline policy. The policy document, I'm gonna attach it from my current working directory. I'm gonna show the content of it in a second, and that's the format, that's the syntax, how you're attaching it with file / and then the file name with and that's it. That's basically the administrator access policy. That's nothing that I created. It's just administrator access default policy that allows you to do any action. And I'm also given the profile, which is peresc10, and this should not give any output if there's no error, and that looks good. And then we're gonna refresh the page for the user, and we should have this new inline policy attached now, which is allowing us to do any action. Perfect. Next one is peresc12. I realized something interesting here. I'm not sure if it's a thing that's done intentionally, but in the documentation on the BishopFox page, it mentions that exploitation can be done with assume role, but we cannot do assume role without having that policy. I'm not sure, maybe that's like a bug or something, but I needed to update that policy to have assume role and then put role policy, which is going to be the real document, real exploitation. And I'm also checking the role, and we need to have a role that we're finding a role that has a trust relationship with peresc12, which will allow us to exploit. So that's the command we're going to use. First of all, we're going to assume role. We're given the role ARN, which has a trust relationship with this user. Role session name, just call it anything, and a profile is peresc12, which will give us the secret access key ID, and the session token. That's very cool. And then after that, we can use the real exploitation with put role policy, which is the other action that's given in the policy documentation. So let's use that technique now with AWS service name IAM, put role policy, the option that we have in here in the action and the policy documentation. Role name peresc12, put role policy -role, which, like I said, has a trust relationship with the current user. And then the policy name, you can just call it another inline policy, like we did in the previous example. Then the policy document, again, I will just attach it from my current working directory. Of course, don't forget to use the syntax for that. I will show the content in a second, and then the profile should be peresc12. And let's see the content for admin.json. You can basically update it with the administrator access policy content, which has full effect, full action on any resources. So that's what we can use. When we send that, we shouldn't get any output. That means we don't have any errors. Let's refresh the page for that role, and as you can see, we now have this policy attached, which is having administrator access privileges. Super cool, very similar scenarios like the previous ones, but another technique that we just learned. Again, now when we assume the role again, since we attached that policy, we're gonna get different secret key, different session token, which have the policy administrator access attached to it. The next one is PrevEsc13. That's another very simple technique here. We're going to the user, PrevEsc13, add user to group. So that's the policy action that we have available. That's the client's command line interface documentation I was referring to. That's original documentation. That's the command line interface documentation that I use when I'm doing the exploitation phase. So as always, AWS, IAM, which is a service name, add user to group, which is the option that we have in the policy document. And then the group name, obviously we are allowed to add user to a group. So let's see which group that we want to do that. We have the admin group with the permissions, with administrator access permissions. So we can just use that group name to add our user to that group. The username is obviously PrevEsc13, add user to group -user. Then the profile would be PrevEsc13. It's a super simple example, but another one worth to know. And if you check the admin group right now, the user PrevEsc13 should appear here. That's it. That's super simple, but another technique to know. And we have the administrator access privilege in this user now. The next one is PrevEsc14. I like this one a lot. This is like with the assume role. I like these examples. You can also refer to the BishopFox documentation. It's also very cool and gives a lot of hints that I use as well during solving all these exercises anyway. So this is the user, and we have two actions allowed: IAM update assume role policy and STS assume role. So let's see how the documentation shows and what these actions mean, what we can do with them. You can also check the command line interface documentation for the command options that we are going to use in a second. As you can see, we need to give the role name, policy document, etc. We'll do in a second. It basically updates the policy that grants IAM entity permission to assume a role. So let's see how we can exploit that. So first of all, we need to have a role. For instance, we can use this default one, PrevEsc Private Service role, that has a trust relationship with all these services that you're seeing, and the permissions are administrator access privileges. So we can use this role that came with default setup when we have this playground IAMVulnerable. So we can use this role to exploit this vulnerability. So first of all, we're going to write AWS IAM, and then we are going to use update assume role policy option that we were attached in the policy. The role name that we are going to use is this one, which has administrator access privileges. And then the policy document, again, I'm going to attach it from my current working directory. In a second, I'm going to show the content for you, and then we're going to just write the profile, which is PrevEsc14. So let's see the content for admin.json. We can just use a default action STS assume role, and for the AWS run for the user, we just need to update this one for PrevEsc14. Super simple, the exact same policy as any STS assume role, or you can just get it from PrevEsc14's policy. You just need to update principal with this PrevEsc14 users ARN, and for STS assume role, you also need to write condition, but we don't specify anything. It's just empty. So now this is our content. If you want to look at it again one more time for STS assume role, and let's send our comment on the other tab. So let's see, we're updating assume role policy. We shouldn't get an error. That's great. Let's go back to the roles and check the trust relationship. Now we should see our user's ARN and the roles trust relationship. That's very cool. And then the next one we will do is obviously assuming the role, which is also in our policy page, in our policy document. So we had two different actions allowed, and we are using them both to do the exploitation in here. We're writing the role ARN. You need to write a role session name. You can just write it anything. It's just an option that we need to write. And the profile would be Prevesk 14. Now, I did a typo here. Let's correct that, Prevesk. Now, I'm going to get an error here. I did some debugging. What is the problem here? I realized later that in the trust relationship, it's not just enough for me to write my current username, but I also need to specify the root user with this AWS account ID. With the same ID, the same thing, I'm not changing anything. Instead of just giving user / whatever user it is, I'm gonna also give root. So without writing that, it doesn't work. The scenario just doesn't simply work. So that's just a trick for you to know. Then it should work in this scenario. Let's try it again with the same comments, nothing changing. We're just updating the assume role policy by adding the root account as well. Root user as well. Let's refresh it. As you can see, we updated the trust policy, and now we can assume the role. If we send it one more time. Perfect. Now we have the secret access key, session token, access key ID for the role. All right, the next one is Prevesk 15. That's a very cool one. That's the Lambda example. Let's see. That's our user. That's the attached policy. So let's see what the policy says, which actions we're allowed to do on any resource. IAM pass role, Lambda create function, Lambda invoke function. These are the actions that we are allowed to. You can check the documentation to see what these means. Again, I'm using that role that we have to escalate my privileges later. It has administrator privileges, which we can use to our favor later. If you see the trust relationship, Lambda appears in the services name for STS assume role, effect is allowed. So that's a policy that that's a role that we can definitely use. How I'm gonna write the document is by using ChatGPT. So I'm gonna ask ChatGPT to create a Lambda function that attaches administrator access policy to a user. So let's use AI to see how we can create a Lambda function like that. It is magic. It's given us the template basically, so we can update it later. Cool. Let's copy the code and let's update it with our own needs. Let's call it lambda.py. Doesn't matter. Let's update this. So we don't need this try except kind of thing. We can just return. We don't need to do error handling here. I think I deleted a line extra here, but I will edit in a second back. Let's see. Yeah, that IAM line needed to stay. I deleted a bit too much when I was deleting the comments. Anyway, I'll update it in a second. So let's change our username. Which name we were, Prevesk 15, I guess. Yeah. And let's copy paste all of this. So what else? We don't need to try except error handling. We can just keep response, and let's also correct the indentation. Username will be username. It's the same that we already specified in the parameter, and the policy ARN would be administrator access. Thank you, ChatGPT. It already got the ARN for it without us need to update anything. And to prevent having any indentation issues, I'm also correcting this a bit because I'm not using a text editor. It's in V, so I'm trying to make sure everything looks okay, and then we're gonna return the response later. But again, let's delete all of this error handling situation. We don't need that. We will return response. We don't need the access key and the secret key. It's already in our environmental variable. We are already configured for that, so we can just delete this part, and we can just keep IAM for the declaration. That's cool. Let's also do the indentation here. That's a bit looking weird, but this looks good. So we specify the username and then the ARN for the policy that we want to attach the user to. And yeah, that's like a very simple Lambda function. We can use that one. In order for us to attach the Lambda function to the command, we're just gonna zip it quickly. Very simple way of using it is zip, and then the zipped file name, and then the file that we want to edit to the zip file. Very simple syntax for Unix systems. So let's start the game. The first action that we're allowed to is create function, so let's do that. It also explains here like the zip function, zip file and everything. You can check the command line interface option as well to see which options do we have for this comment. You can just read the documentation. I'm just showing it in here quickly to give you an idea. Then AWS, then the service name Lambda, and then the function that we have, or the option, is create function. Function name, you can call it anything, doesn't matter. Then the runtime environment would be Python 3.11 it should be, but you can just check it with like Python 3 -- version. Just specified in here. And then the role ARN would be this one. The handler would be the function name that we given in the Lambda function. It's called Lambda handler. We can just give it in here. Then the zip file name, which should be lambdafunc.zip. And again, we need to use the syntax to attach the zip file as follows. Then you need to specify the region, US East 1 we're gonna give, and then the profile is Prevesc. Which one was this? 15, I guess. Perfect. We created the function. So the second part of the exploitation is invoking the function. Let's clear the page a bit. And then again, the same format, AWS Lambda invoke function. You can just go to the documentation as well. It should be invoke. On left side, let's click there. It will just simply invokes the Lambda function, the one that we just created. So let's give the function name. We call it test, if I remember correctly. That's the one. Then the output, the txt, that will be the output that we are putting out of the comment. And then the region, we gave US East 1. The profile was Prevesc 15. So let's see what kind of output we're gonna get now. And we get an error message, so we need to correct it. I think I did a mistake in the file name, if I remember correctly. So let's see. Output also shows that the handler is given wrong. It says not enough values to unpack. So let's see, where can I update it? And yeah, if you attach it like that, lambda handler, that should correct the issue. And when you send the same comment again, just change the function name because we created it already, so we need to just update this one. The rest should be same. Then we won't get any error messages anymore. That's great. You can also read the output.txt to see that we don't have any error messages. That looks good. If you refresh the page, we're gonna get administrator access just like that. It's a very cool one, very different than other services that we use so far, but another cool example. Prevesc 17, that's another Lambda one. So in here we're allowed to update function code and function configuration. You can just check the documentation here, function code, function configuration. It basically updates the Lambda function code. Cool. Let's see, we can just create one quickly, like a test function, and then update the function code with the code that we want and update configuration. Let's see. First, we need to have a role that we can use, like a role with high privilege policy attached to it. And we can see that in the trust relationship, we see Lambda. That's cool. First, let's create a function to make sure that we can actually use it to update the function code later. Let's copy the lambda.py Python code that we have in the previous example and copy the simple.py and just change the code in the simplest way possible. Let's just simply print something like what's up, hello world, whatever you want. It's just like a simple one to create a Lambda function so that we can update it later. Let's create the function with the comment that we had in the previous example. Super simple. Super simple, and we already learned this in the previous ProEsk 15 it should be. As you know, AWS, Lambda, create function. The same options that we used in the previous example, nothing different. The function name that we are given, just give anything that you want. Test, simple, ProEsk 17, hello world, anything. And then the runtime should be Python 3.11. My environment has 3.11 as far as I know. And then the role should be the one that we were talking about. That has a trust relationship with Lambda service and has administrator access policy attached to it. Handler, I will give simple.lambda handler. The policy should be prevent. The zip file that I'm gonna give is in the same format, file b // and first let's create it actually. Zip simple.zip, simple.py should do the work. So we created the zip file just like that and put the simple.py in it. And let's use the same syntax to put the zip file there. The region, of course, you need to specify US East 1, the same example as the previous one that we are going to give. And just like that, let's create the Lambda function. That's cool, we have it now. And we can actually do the exploitation after that because we just needed a Lambda function. If you already have it there, you can also use that one, doesn't matter because resources should be all. That's why we did not specify the profile here. We just created a Lambda function without any profile attached to it. So let's use the privileges that we actually have to update the Lambda function. Let's use the previous one that we have from ProEsk 15, but let's update the username to ProEsk 17 first, which is the current exercise that we are doing. Let's copy paste the username, ProEsk 17, and that existing Lambda function with role-user, response is same. Attaching administrator access policy to it. And then the next one we're going to do is AWS Lambda update function. Function code, sorry. And then a function name, like I said before, whichever we already named in the creation, ProEsk 17 func. Let's give that to the update function code option. And then the zip file, we need to give the new file that we're going to create from lambda.py. Be careful, don't give the old file. If I can type. Perfect, now we created this file. Let's give it in the same same syntax, don't forget that. Of course, we're going to specify the region. We need to specify profile here as well, since our current user have the capability to update the function code. We need to specify that. Perfect. That looks like that's a good response. And then we just invoke the function, and then we update the function code. Just a quick update on my typo. Anyway, when we update the user's page, we're seeing the administrator access is attached to it. The next one is ProRisk 20. That should be the CloudFormation one. Let's see. So let's see the policy. That's correct. The actions that we have is IAM pass role, CloudFormation, create stack, and describe stacks. So that's a new service that we did not work before. And you can just check the documentation to make sure that you understand what CloudFormation is. What do you mean by the action create stack? What is a stack? What's it used for? So that's a homework for you guys to do. Just go to the documentation for CloudFormation. From there, you can also choose the command line interface or just the documentation first to understand what is it, the concepts, the templates, the stacks. That's a very good practice to first understand what's going on in here rather than just going to the command line interface documentation and trying things out. Maybe it will work as well, but it's always good to have good foundation to understand the security principles. So highly recommended. Anyway, one way that we can get the template is the following URL that I'm giving it in here. So you don't need to create it from scratch. So that's basically a template to create a new user. Now, when we're doing exploitation, of course, we're writing AWS and the service name, CloudFormation, and then the create stack. And you can just go to command line interface documentation to see how we can create a stack. What kind of options do we have? The stack name that we need to give. And then the template document, whether we can use the one that we already saved from that URL that I just showed, or we can also give the template URL. They're both the options. So I will use the template URL one since we already have the URL in here, or you can just use the template body, but I will change it in a second. I'm just showing it in here as a different option if you want to use. But let's delete that and let's write the template URL because it's already here. What other options do we have here? We need to give the role. We can use the admin access role, which has trust relationship with CloudFormation and have administrator access privileges. So we need to use the ARN for this role. You need to give the capabilities. Again, I highly recommend to check the documentation for it. Which capabilities do we have? And we will get the capabilities underscore IAM. And let's give the capability underscore IAM. The region, you can just give US East 1 again. The profile should be ProRisk 20, I believe. Then the stack is created. We have the stack ID. That's very cool. The next action that we have on this one was describe stack. So that's the next option that we are going to use after creating the stack. Let's type AWS, CloudFormation, describe stack, and you can refer to, again, command line interface documentation to see which options do we have to run the comments. Again, we need to give the stack name. The stack ID is already given in here. You can just copy paste from the created stack. And then the region, again, it was US East 1. The profile should be ProRisk 20. I think we're good to go with these options already. Awesome. We updated it. It says create in progress, so I need to wait in a bit. Once it's created, if I run the same command again, I will get the secret key, access key, ID, etc. Let's run it again one more time to see the output with more information. And here we go. We got secret key, access key, and we exploited it perfectly. Of course, what you can do is you can add this information to your AWS credentials file and create a new profile in this way and run the following command to get the access ID as well if you want to log in to the console with this information. So what you need is the access key, secret key, and the account ID, which is coming from this command. Super cool. We just exploited this one as well. So the next one is not with numbers, Peresk 20, Peresk 21 or something, but this one is Peresk EC2 instance connect. We go to that user, we're checking the policy. We have few options on EC2, describe instances, EC2 instance connect, send SSH public key, and send serial console SSH public key. Cool. So what we're going to do is first we're going to describe instances. The first option that we had, first action that we had in the policy. We can give the region. I think it should be Paris, right? EU West 3. I'm in Berlin. I have no idea why it's in Paris, but anyway, I created the EC2 instance there, obviously. Then we're going to give the profile, which is the instance connected should be. Output is going to be text, and let's see the running instances in this way. And there are some useful information here: AMI ID, instance ID. We're seeing the IP address, the public IP address here. So these are useful information that we're going to use in the next steps of the exploitation. The next step that we need to do is using the send SSH public key option. So first we're going to type AWS EC2 instance connect, and then the send SSH public key, which was the action that was given in the policy page that we are allowed to do. Just go to the documentation to see which options do we have, like the instance ID, instance OS user, SSH public key. And the SSH public key we're talking about is our current user's public key. So it has nothing to do with any information on the EC2. So we're basically using our own public key to define and to connect to an EC2 instance that's running on a given region. So we don't have any information about the EC2 instance besides what's given in here with the describe instances comment. So we're just given the instance ID. Since this is a Ubuntu machine that's given in the output that we just seen, instance OS user should be Ubuntu, which is the default user to connect to. And the SSH public key, I did a typo, but I'm going to correct in a second, should be in my for my current user under the home directory. It should be .ssh and ID RSA. .pop. So it has nothing to do with EC2 instances, PEM file or like key file, nothing to do with that. So we're gonna give also the region. I did another typo. Instead of EU West 3, I wrote UE. So yeah, I do a lot of typos. I correct them later. The profile should be Peresk EC2 instance connect, something like that. That's correct. Yeah, let's correct the typo here. SSH public key and EU, not UE. And when we send the comment, we are getting the request ID and success output, and success is true. That's great. So we're just going to use our public key to basically connect to that EC2 instance that's running using the public IP address. Ubuntu is the default user, and as you can see, without any public key of the EC2 instance or any password details, nothing, we're just able to connect like that. So super cool. another exploitation technique. What we can do is we can just get the secret key on that EC2 instance and add it to our profile later. So we can actually show that we fully compromised it. So it's a default URL that you're going to see it in here. So here we're extracting the credentials using the metadata API. We're going to use this information to add a new profile in our AWS credentials file, and we can check the account like that. Just adding these options: access key ID, access secret access key, session token, just coming from that output from the metadata API. After adding that, we can also check for the account ID, the STS get caller identity comment, the account ID as well. So what we can do is just go to the console and log in as this user with the access and secret key that we already have. So that was all. I think we covered 10 scenarios today, and I think I covered already most of the scenarios from IAMVulnerable. My personal comments: I love this playground. There are so many different privilege escalation scenarios, but it taught me a lot of different techniques that I didn't know before. It was super cool to see what kind of privilege escalation scenarios you can have, especially when you combine it like with different services, different actions that you can do. It was a very brilliant one. Kudos to BishopFox for this great exercise. They have a few more playgrounds like that. I will definitely create videos on these as well. I have plenty of time in these days, and I dedicated myself to create some YouTube videos. So stay tuned, guys, and cheers.